All right, let's take a look at two variable inequalities today. So two variable inequalities are going to be a little different than one variable. We'll see how different. So remember when we were graphing lines, how you'd start at the y-intercept, you'd count out the slope. So just to make sure you remember, why don't you try sketching the graph for y equals negative 2x plus 3. Go ahead and pause the video, sketch your graph, and then come back and let's see how you did. Well, welcome back. You might not be able to see my graph paper, but I started my graph at y equals 3, and then because the slope was negative 2, I counted down 2 squares and right 1 square, and then down 2, right 1, down 2, right 1. I could have also have gone up to left 1, but there's my line. Now, we've been talking a lot lately about what does it mean to be a solution to something. So let's say we take our line, y equals negative 2x plus 3, and we ask ourselves, is 4 comma negative 5 a solution to our line? Well, remember that to test for solutions, the secret is you plug the number into the problem and see if you get a true statement. So I plug negative 5 in for y and 4 in for x, and I look to see, do I get a true statement? Well, it turns out that yes. If I work the x value through the right side of my equation, I get negative 5 equals negative 5. So 4 comma negative 5 is a solution. What about negative 1 comma 1? And I just wonder, could you answer my question without having to plug it in? Is there a way to know for sure that negative 1, 1 is or is not a solution without having to do any calculation? Think about it for just a moment. It turns out it's not a solution, and that is because negative 1, 1 is not on the graph for that line. So go look on your graph. Find negative 1, 1. You'll notice it's not on the line. If you go to your graph and look for 4 comma negative 5, you'll see that it is on your line. So being on the line makes it a solution. So now you might be thinking, hey, we've been doing inequalities. Why are you going back to equations? That's because we're going into this. What happens if we now put an inequality symbol into our line? Y is greater than or equal to negative 2x plus 3. So what does that mean? Will there be more possible solutions? How do we do it? Good questions. I think we should explore that. So let's just do a quick flashback to one variables. And let's look at the difference between equation and inequality. So over here on the equation side, 3x minus 2 is 16. So I solve, add 2, divide by 3. There's the answer, one number, done, that's it. I could draw a graph, but it's kind of pointless. Now let's come over here and look at what happens when it changed to a greater than or equal to. We still solved as an equation to find our boundary point. So x equals 6 was our boundary point. Because it said greater than or equal to, we filled in the circle on 6. Then we went and tested a point, and we like to test 0 because it's easy to plug in. When I plugged 0 into the original problem, I got a false statement. So I wasn't going to shade towards 0 because that's not where the solutions are. I shaded away from 0. So I still solved, but then I had to do a testing, and then I had to do a shading. So I still solve, just like before. Then I had to put some kind of circle based on my symbol. Then I had to test. Then I had to shade. I wonder if that would translate into two variables. Well, let's look at the difference between them. So we're going to look at the difference between this, where we graph y equals negative 2x plus 3, equals one line done, that's it, and that. When I have an inequality, I still graph, just like I did over here. So I'm still graphing. But now I have to do the testing and the shading. So now, instead of testing a single 0, I'm going to test the point 0, 0. So 0 for both variables. When I plugged in both 0 and 0, I got a false statement. Well, on the number line, if it was false, we just shaded left or right, whichever was not 0. Well, here, instead of left or right, I have this line creating a divide. It's either this side of the line or that side of the line. Since 0, 0 was living in this sort of lower side of the line, and it was false, I shaded over here. So that's the difference between this and that. This is equals, this is greater than or equals. We call this a linear inequality. And problems like this are solved just like with one variable, with just the little added dimension of an added dimension. So graph y equals negative 2x plus 3. What that's giving you is your boundary line rather than a boundary point. So we get our boundary line. Then we need to choose the line that matches. We'll get to that in a minute. You're going to test a point. 0, 0 is nice. Anything not on the line makes a good test. And then we shade. Now wait a second. Let's get back to that number 2. What exactly do you mean by choose the line that matches? Well, let's think about back in the day. So we're going to start a new example. Y is greater than negative 1/3 x minus 1. You notice this time it says greater than, not greater than or equal to. So back in the old form of one variable, when we needed to show the difference between x greater than 2 and x greater than or equal to 2, the x greater than 2 had this open circle. That's how we showed that that's our boundary point, but we weren't including it. It was an open circle, kind of like an imaginary circle. When it said greater than or equal to, we colored it in. So the open circle showed it was just greater than. Well, on our two-dimensional graph, we're not using circles. We're using lines. So how do you think we're going to show an open line? And we do it like this. So when we go to graph our line, rather than connecting the dots solid, we connect the dots with a dotted or dashed line. That's how we show that it's like an open line because it has holes. It's open. You could walk right through it. So we use an open line. Now we test and shade. So in this case, 0, 0 turned out to be a true point. So 0, 0 was a solution. So that's where we shaded. And I always like to think about it as you want to shade where your true friends are. It's almost like you're coloring where you want to hang out on this graph. If 0, 0 proves to be true, you want to hang out over here with all of your true friends. If 0, 0 had been false, you would have been hanging out below the line, because if 0, 0 was a false friend, then everybody under the line would have been your true friends. So just think about that. Always shade where your true friends lie. So now why don't you try one? Here's one to try. I want you to graph it, test it, and shade it. Pause the video and come back when you're ready. Welcome back. Let's see what you did. Now, the slope means that you would have started at y equals 2 and gone up 4 right 1. Having a less than or equal to meant there should have been a solid filled in line. And when I tested 0, 0, I got a true statement. So there it was. There's my graph, my solid line. There's 0, 0. It was true, so I'm going to shade over on this side where all my true friends live. Okay, here are 2 more. Go ahead and try them. Pause your video and come back when you're ready. All right, here's the first one. Y is less than 5/2 x plus 3. Dotted line. 0, 0 was true, so we shaded that sort of lower right side. And on this one, we have to first solve to get it into slope-intercept form. So y equals 2x minus 5. You can see my solving process. And then 0, 0 was true, so I shaded the side with 0, 0. All right, well, that is linear inequalities. So at this point, if you're not feeling super strong about linear inequalities, it might be a good time to go back, rewatch the video, kind of think your way through it, maybe try a few extras and get feedback from me if needed. If you're feeling pretty good, then why don't we go further? Let's enrich a little bit. So why couldn't we do this with any graph? It doesn't seem like linear graphs should be the only one I can do this with. I can graph something else. I can make a solid or dotted shape. I can test, I can shade. So what if we had a parabola? Well, if I graphed the parabola, just y equals x squared minus 4x plus 3, this is what I would do. I would graph some points, try to find that vertex, do some reflections and everything, and I'd get my nice little parabola. However, if I look at the original problem, it says less than. So think about how that parabola should be drawn. Ah, yes, it's a dotted parabola. And when I did my test of 0, 0, I got a true statement. Now with a parabola, you have inside the shape and outside the shape. 0, 0 was outside my U shape, so I shaded outside of my U shape. Okay, here are 3 more. These are going to be a little bit trickier. So take the time, build some tables of values, graph each one, watch out for solid or dotted. I highly recommend that your default setting should be a dotted connection. And if you need a solid one, you can always go back and sort of connect it, smooth it out. It's a little bit harder to erase little gaps to show dotted. So that's why I'd recommend start with dotted, then connect if you need solid. So here are your 3. Pause for as long as you need to get these 3 graphed and figured out. Not always bad to even use Desmos to help guide your thoughts. Pause now. Okay, welcome back. Let's see what you got. There's A. I made a table. It's a little exponential curve. Less than meant dotted. 0, 0 was true, so I ended up shading under my exponential curve. All right, this was a parabola, kind of sitting off to the side. It was solid because of greater than or equal to. And when I plugged in 0, 0, I was getting 0 was greater than or equal to 9 plus 3/4, which I already knew was false. So that meant I was shading inside my parabola. And this one might have thrown you for a loop, but when I graphed the line x equals 2, that's a vertical line. Because it was less than, I made it dotted. And then I shaded left for where 0 was true. Think of this one like having the old-fashioned straight number line with the open circle shaded left. But what I've done is taken that number line and stretched it. So here's that open circle stretched out. Here's that shading stretched out. Okay, last one. See if you can get this one graphed and shaded. Pause your video, resume when you're ready. There it is. Absolute value, it was dotted. 0 was true, and because 0 was right outside the V, right down there, I shaded outside my V. So that is 2 variable inequalities. Good luck and keep practicing.